Everybody look at me. Everyone look at me. No one talking.
Go to your seat.
I was going to use your words and say, get your cheek on button.
I like you.
All right. Everybody looking at me? Come on, look at me. Look up for a second. Look at me. Come on, look. Okay. So we have had 6 homeworks in a row. Each of them, don't look at me. Each of them had, some new concepts as we went along. So I have sensed, as I've been working with people who have been coming after school, that it's piling up a little bit. It's really tough in this class, listen, because May 14th is the deadline. It's not like some classes where it's really easy, actually I'd say many classes, it's really easy for the teacher to think, oh, well, not that big a deal, we'll just not cover this little thing this year, it won't even matter. With the AP test, I don't have that luxury, so it's a bit of a challenge to kind of keep you on pace, but I really, eyes on me, I really work hard to keep your stress levels manageable as I can. For example, if you're not caught up in homework, like, please don't spend time at home getting frustrated. It doesn't help anything, okay? Like, find a way to come work here. Like, I guarantee you, things will be much better. You'll spend less time, you'll make better sense of it, you'll feel better, okay? So find a way to come here. Today I can't stay after, tomorrow's not so good, but I might be coming on Monday. So watch for the text messages. Tuesday was probably pretty good, pretty solid, I should be here. Wednesday during the entire school day I have to help with the AP test. But like about 2 o'clock I should be done, and I should be able to help, so watch for that. Yeah, ECT, sorry. You don't see me again until Thursday, so you do have a lot of time now to get caught up. Okay? But again, look, hey, don't spend time at home getting frustrated. It's totally fine to say, hey, I think I understand some things, I'm going to try again, get through what you can, but when you start getting frustrated, just move on. You're practicing that, one, to keep your stress level manageable, but you're also practicing it because that's how the AP test is. You get the same points for easy questions as hard ones. So only a crazy person would sit there and try to do hard problems when 3 easy ones are just waiting for you. Okay, so don't do that. Questions? Okay, also to help a little bit, I'm not giving a new homework packet tonight. Okay? Depending on the questions, we may start discussing the concept. We won't have a homework packet, but I'm hoping that today during class, it'll be highly valuable time to discuss. We'll start with the green, okay? And if we get all 3 green questions, we can even go back and perhaps hit a few from previous packets. But first question, anyone who really did diligently try to work on the green, came to class prepared with specific questions, we can kind of start with one of those now. Just in first 13. No specific questions. Okay, so listen. Okay, once again, hey, focus. Okay, it will do absolutely, it helps. It's of zero worth to just listen. Like, you've got to think with me. I say it all the time, but you can go home, you can get on YouTube, you can look up related rate problems, probably find 100 different teachers explaining related rate problems. And I really feel like if you watched all 100, you'd probably be no better off than if you had watched none of them. Because it's not the watching that helps, it's the interacting. Okay? So today, I really want to give away as many points as I can for lots of interaction, because that's what helps. And one more thing, you're not trying to learn how to solve this problem. You're trying to pick up the patterns, right, that are present in all related rate problems so you can solve any problem. Question? Alice.
Sorry, I just have a quick question. Was 6 meant to be no calculator?
So raise your hand if you felt a high level of stress on 6, if you really did try to get through it, and you're like, this is just not making sense. And okay, 6, you have to use your calculator. That was my mistake. I'm trying to manage your stress level, and I do not. That was just totally my mistake, so I apologize for that.
She spent all of Kyle platform. That's it. She just told me that. She's trying to give her the tickets. Students get it, Maddie. They help with your grade.
Yeah, 6 you have to use. 6 does require a calculator. Here we go. I also discovered something yesterday that I had not noticed before. The little help red is actually better if we spell it like this. And think of it as read or read. No, I've learned my lesson. So, so let me talk about this problem. The idea is like they picture that flag right there as being a light. Okay, the light, like a street light, like the top of the flag is a light bulb. Okay, so the light shines everywhere. Okay, I'm the person who's walking, so I stand here. The light can go everywhere, but it cannot go right in front of me because I'm blocking the light. Pretty good?
Yes.
Awesome. So draw a picture of that. So here's the street lamp, 8 meters high. Here's the person, 2 meters. The light shines like so. Yellow being an appropriate choice. In all my pictures as a child, yellow was light. I never drew an orange sun. So. This needs to be black for a shadow.
I don't have that luxury. Mine's all gray.
That is true.
That looks like a shadow. Let's see, look at that. Look at that shadow.
Okay, questions? Everybody feeling good about that? Okay, once we get the situation clarified, we pay attention to this. So R stands for rates. So you look how helpful this is. You read the problem and you identify the rates. Okay? So I need rates. Now, what I do is I build a Danica's chart. So I need someone to help me. What are the rates? We're going to pay for multiple people here, so you can keep raising your hand. What are the rates that are, what rates do I read about? What rates am I reading about, Mikkel?
The constant walking rate.
So I have the constant walking rate, which is it's my best animation. Okay, walking along right. I have discovered it after doing a lot of related rate problems that rather than kind of think of his walking rate, it's better to think of the rate at which the green distance lengthens. That's an easier way to do it. So I would label my picture like this. Call that distance B. It doesn't really matter, A, B, whatever. So the shadow length over here, I'm going to call that distance A. So how many would have said the rate at which he's walking? 2 points. Okay. Something I noticed last period that I kind of missed. Oh, please, question.
Oh, no.
Oh. Something I noticed last period that I kind of missed out on was, it's actually Cambria asked this. It was a really good question. She kind of had in her head that we would only list the rates that they actually mention as far as having a value. but you also list rates that they are interested in finding. So sometimes the rate you list won't be known, it's what you're searching for. But you want to get all the rates listed. So other rates we read about with our hands. To be a related rate problem, there's got to be at least two. Otherwise, it wouldn't be related rate. An only child has no relatives or the cousins and things. That didn't make any sense. Skip that analogy.
The rate at which he's walking away.
Yeah. So the walking rate is going to be the rate at which B changes. The shadow rate is the rate at which A changes. So I write on my paper dA over dt is 4/9. And we're looking for dB over dt. So how many had their hand raised would have said that had I called on you? Two more. Okay, the reason I build the Danica's chart is because now that I have rates, I can list the corresponding amounts that go with the rates. So I can put a B here, and I can put an A here. Question. So the little helper over there, read, we added the A because some people yesterday were struggling a bit to remember that we get the rates, and then we need an equation that involves the amounts. And all related rate problems follow that pattern. You don't focus on the rate, you actually focus on the amount. So let's see. This is a common related rate occurrence where they're giving you similar right triangles. So a similar right triangles, coming up with an equation is really easy. It's just a proportion, and you can set up the proportion pretty much any way you'd like. In fact, it's so easy, I'll just pick on some volunteers and give away points. So I just need one person to raise their hand. Preston's in. So all you have to do is look here at the triangles. You've got the big triangle and the small within.
Okay.
All you have to do is pick a side of either triangle.
Bottom side.
So what would be the length of the bottom side?
6.
6.
Oh, I thought you were supposed to make one up.
Oh, that's my bad. So we know this side is 8.
Okay.
We know this side is 2. If it's a side length we don't know, we just want a symbol to represent that length.
Oh, just like C or something?
Fair enough. So you're looking at this side here.
Oh, okay.
So a convenient way to do that would be just to say B plus A.
Okay.
No, you're fine. That was my bad. So we got B plus A. 2 for Preston. Other volunteer? Let's go Elijah. So now all you do is you pick either, so this was one side of the large triangle. So you can either pick another side of the large triangle, or you can pick the corresponding side of the small triangle. It doesn't really matter.
So for the small triangle would be A.
There we go. So we just put an A right here. Oh, actually, I'm not going to do that. Because similar triangles are really flexible. I'd rather have my variables in the numerator, so I'm going to put it over here. Totally legal. So 2 for Elijah.
Sweet.
So this is the bottom side of the big triangle. You just have to make sure you establish a consistent pattern. This is the bottom side of the little triangle.
So why did you do that? Why did you take the bottom?
Why did I move it?
No, why did you just take the bottom of the triangles? Are you just trying to find the length of that?
What I'm trying to do is get an equation that involves the amounts.
Okay.
And so because I'm looking at similar triangles, I know it's just going to be 2 fractions equaling each other. And we'll do a couple of more examples to help. 2 for Mikkel. 8.
So under B plus A would be 8. Right?
Very good. So take this side of the big, so now take this side of the big. 2 for Hayden. Somebody else? Let's go here, Alex. So I put a 2 there. Question.
Could you have done the top side of the triangle? Could you have divided it by the top side of the triangle?
Yeah, so I could have done this. I could have said B plus A. So that's the this side of the big divided by the similar side of the little. The computer does that once in a while.
Oh, it's gone.
Back. Oh, it's back. Thank you. So I could have done that, and then so this was the big side, little side. Then I could do like 8 over what would it be, 2?
You just literally just like kind of.
You just make it up. You just have to make sure it's consistent.
How does the bottom equation?
So let's see. This is this side of the big triangle, right?
Okay.
This is the similar side of the little triangle. This is this side of the big triangle. And that's the similar side of the small. Similar triangles are easy because the pattern can be pretty much anything. Let's do another one, just more points. So somebody, just do it different. Pick a different way to make a ratio. Looking for hand. Like you're all deer in the headlights, like we can't do it different.
Can you just like flip all of them? So it's
Yeah, you can say, oh, 2 over 8 is A over A plus B. It's all the same thing.
B plus A.
Okay?
A over B plus A equals 2.
Now, look, I prefer this method because I like to get the variables in the numerator. It's simpler, but the others are not illegal. I kind of like to get rid of those fractions. So what I do is I multiply both sides by 8. And I also multiply both sides by 2. So these divide out. These divide out. Question? Please.
I just multiplied by 8 and then 8 over 2 simplified to 4. Is that?
Even better. 3 for Maya. She said just do, since 8 and 2 are common something or other. So like this, 2 is a factor of 8. So now I just have B plus 8, sorry, B plus A. It's equal to A, this becomes 4, so 4A. So B is equal to 3A. So question for the whole room now, what's the step that followed? So again, we're looking for a related rate pattern so that we can apply it to any problem. What step comes now in every related rate problem? Fred, what step do we now execute in every related rate problem? If you're having trouble, you should go back and read. So, not a very good hint apparently. Bad joke. Grant?
You take the derivative of it.
So I take the derivative of this equation with respect to time. How many knew that? 2 points. Somebody tell me exactly what to write. Let's go, Elijah.
dv over dt equals dA over dt.
Point. It's at this moment, well, you pull out the 3. So you got dB over dt. Okay, at this moment in all related rate problems is where you are on your own. So this isn't going to help anymore. Other than rereading sometimes always helps. So now what? Elijah's in. So if you have a question, keep your hand up. Lindsay's in. So these are 2 points each. Preston, Sarah, Brennan, Curtis. 1 second. Sorry. Austin, Avery, Allison, Lindsay.
Since we know what the A and B is, we can plug that in.
Mr. Twitchell, how can I help? Sorry.
I just need to take one of your students.
Oh, go ahead.
Awesome. Jolena needs to come with me. All your stuff.
So this becomes,
Good luck.
and I always put in the units, meters per second. Please.
If it's multiple choice, like the answers, will it ever have units on there?
They might have the units with each answer, but of course you don't have to stress about it. I've never seen one where they try to trick you.
So all the units will be the same if they do have.
Best I can remember, I don't recall any tricks on that. Can't never guarantee, but I don't recall any, so. Questions? Please, what?
It's like, I get how you did the problem, like, where's your thinking from looking at the picture of the triangle to writing down the proportions of the triangle?
Say one more time.
Like, where do you get from drawing the picture of the triangle, like the 8 and the 2, to writing the equation of b plus a divided by 8 equals a divided by 10?
Oh, I'll give you my answer. If it's not what you're thinking, just ask again. So I know I need an equation that involves amounts A and B. When I look at this picture, one advantage I have on you is experience. Like, I've done enough related rate problems to remember that big hidden ideas in the related rate problems are Pythagorean's theorem, similar triangles, the area of a circle, circumference of a circle, SOHCAHTOA, like specifically sine is opposite over adjacent, that sort of thing. Those have been, over the years, some hidden formulas that they don't mention, that I have to just look at the problem and go, oh, this is one where they want me to use similar triangles.
So are you just trying to get it in terms of a and b, so you can eventually get the derivative of it, to plug in the rate?
So 4 points for Elijah. Whoa. Okay, listen to what he just said. That is a key to every related rate problem. The whole reason we start with the rates is so we can see what amounts are involved. Because we always write an equation with the amounts, and then we always take the derivative of that equation involving the amounts to get a new equation that shows how the rates are related. So that's the cycle of a related rate problem. Identify the rates, so I know what amounts I should be worried about. Get my equation that uses those amounts, take the derivative of that equation, I get a new equation showing how the rates relate. That's why it's called related rates. Okay, good. 2 more points for Elijah. Okay, what he just did is what everyone needs to do, either directly by talking with me or by just leveraging another person's question. Oh, I keep forgetting to turn off the stupid sound. This happened last time, right? You can hear the echo. Hear it?
Echo.
Cool.
Echo.
Still want the feedback to be going.
Echo.
It happens because that microphone is an environmental microphone, so it's designed to pick up sound from a large distance. Put a cone on it and spy on people. Seriously. Get Preston's megaphone, put that on the front of that thing, you know, go in the back, see how far away we could hear people. Like, that'd be cool, huh? I don't know how well it would work, but the microphone's highly sensitive. It's meant for outdoor, picking up sounds from a large distance, that sort of thing. Questions?
This or a new question?
New problem.
Number 7.
7. Yes. Okay. I mentioned last period that the reason we end up spending a couple of days on related rates isn't because you're going to have a whole bunch of problems on the AP test that are related rate. My recollection is the test is worth about 108 points. maybe 4 or 5 of those 108 would be related rate problems. Okay, so not heavy, but the problems have a lot of value because they help you sort out the difference between amount and rate, and what do we mean by derivative, which is heavily tested throughout the test. So, okay, hands up. What's the first thing I'm going to do?
When the area is
We want to write down the rates. So I was helping someone this morning, and literally, oops, wrong one. All I had to do was say, write this down. By writing that down, they did better. Well, there's that, you know. 2 points for Maya. Depends. What's next?
Identify the rates.
So we're looking for the rates. We need someone to raise their hand and volunteer something. So these are all worth 2 points. So we got Mikkel, Ali, Maya, Avery, Elijah, Tristan, Brennan, Tessa, Rachel. Right? Preston.
If you're looking at the amounts, would your amounts be the radius in the area?
What I would always do, it really will make the problem easier, is always start with what rates they talk about.
Okay.
And then from that, list the amounts.
The rate of the area,
So how do I write that?
would that be 2R?
Oh, simpler. We just want to write the rate of area is just this symbol.
Oh, okay.
So that means the amount symbol would be what?
A.
A.
And do we not know that one? Is that the one we're trying to figure out?
Let's see, when the area in square units of an expanding circle, so
We're trying to find radius.
got circle getting bigger here. Yeah, they don't tell us this rate specifically, so I don't write it down. Oh, there we go. So what else can I write on the board? Allison?
Equals 2R?
Okay, let's write that down. 2 points for Allison.
Oh, wait, would it be DR over DT?
Yeah, let's write this first. I want everyone to see it. Okay. 3 for Allison. 4. Okay, this is wrong, but we got to know why. So hands up. Come on. Why is this wrong? No, it's fine. Why is it wrong? Hands. Maddie?
Is it because it's increasing twice as fast as the rate of the change in the radius?
Right. Let me read this back to you. This says the area of the circle is increasing at a rate that is equal to twice the actual radius of the circle. Does it say that the area is increasing at a rate that is twice the radius? It doesn't say that. It says the area is increasing at a rate that is twice the rate at which the radius increases. Wait, you need to say that again. You need to see it? Mikkel?
So you would do dA over dt is equal to 2 dr over dt?
There we go. Because they're comparing two rates, not amounts. So, 2 for Mikkel. Okay, who had their hand raised when I asked Maddie what was wrong about this? 2 more points. Okay. So over here I have dr dt, and I have r. So again, trying to help you see the pattern that exists in every related rate problem. Questions? So now, Allison's in, Elijah's in. That means you got 2 points. Maya, Cambry, Tristan,
Are you asking now what?
Ellie. Yeah, now what?
Oh.
Preston, Brennan, Mikkel, Cambry.
Now you define an equation with the amount.
Perfect. You are going to say what Cambry said, give yourself 2 points. So you find the equation that involves the amounts. Somebody, what is that equation? Elijah?
Area equals pi r squared.
Perfect. Two for Elijah. Question.
Can you explain why it's area equals pi r squared?
So I'll get you to say it back to me, then it will stick in your head better. So what's this say again? And then what's the R stand for? Rates. So we read carefully, right?
Yes.
And we got the rates
Yes.
written down over here. What does the E stand for?
Accessory questions.
What does the A stand for?
The equation with the counts.
Perfect. So he looked here and said, okay, we're talking about a circle that's getting bigger and bigger and bigger. So what equation uses A and R and involves a circle? That's area, pi r squared.
Okay.
Pi r squared is the area you see. Good. Oh, I can't, the song just doesn't help me. So. We good? Too compressive. Now what? Go.
You take the derivative of it,
So what's right of it?
you do dA over dt,
Why is it capital A?
and then you can take the pi out.
Just tradition. It's nothing special. Say
You can
again.
take pi out, and then it's gonna be dr squared over dt.
2 for Ellie. I don't think so. I think they'd be lenient on that. Although I do think it's best to use the symbols they use just to be safer. So 2 for Maya. Now what? Go.
So now pi is a constant, so you just bring it down, you find the derivative of r squared, which is 2r, dr over dt.
Perfect. 2 points. Okay, once you get to this point, this little help up here is better than I thought. You read the problem, right? Get the rates, get the equation that involves the amounts, take the derivative, then read it again. Like, seriously, you got this, now read the problem again and see how this helps. So read the problem again and tell me how that helps. Sarah?
Well, the derivative of area equal to 2 dRdc.
Oh yeah, wait a minute, hold on a second. Somebody said something the other day. They said, oh, it's like U substitution, and you're right. It's like finding things that are the same and making replacements. So 3 points for Sarah. She saw, hey, wait a minute. We also got this as a clue from our reading. So she's going to make a replacement. Somebody tell me what replacement is she going to make?
dA over dt would be 2r, 2dr over dt.
Perfect. So just like U substitution, we plug it in. Two more for Preston. What's the goal of the problem? Find the radius. Hey.
You divide the dr over dt out.
So I can divide both sides by dr dt. 2 points for Hayden.
When you divide it, would you multiply?
I divide this side by dr dt, divide this side by dr dt. Lindsay?
Can we also divide by 2?
Divide both sides by 2. So what's the new line, Lindsay? What should I write here?
1 equals pi r.
2 points for Lindsay.
Yay.
Yeah.
One last question going back to what we were talking about when you found that dA over dt equals 2 dr over dt. In the question, how do you know that it's the rate of the radius?
Careful reading. So it says when the area, so that would be A, of a circle is increasing. So the area is
Yeah.
increasing. So it's not the
Okay,
area.
so that's the rate of the
Yeah,
area.
they're talking
So
about the
that part's
rate.
clear. But what about the radius? Because it just says twice as fast as the radius.
They're tricky is how they write it. I get you. Okay. So when the area is increasing twice as fast as the radius is increasing,
Okay.
so they're talking about the 2 rates. But
Okay.
I'm with you on that one. Tricky.
It's tricky.
Did I talk about the room 13 stories underground?
No.
So I read an article once that said that, it's interesting, it was like kind of like on some obscure website. It's claimed that the people who write the AP test, they work in this special building that you can't see a building. Like it's just a parking lot. Like the cars in the parking lot, right? And there's just like these stairs, and they're 13 stories underground. It's a good story.
I wouldn't be surprised.
And then you get down, they go down there, and then they put on these black cloaks. Like, so you can't see their faces. And there's like a big roaring fireplace over here. It's like a cave. And then they just think up creative ways to drive you crazy. Seriously. Like I'm sure they wrote out this problem the first time and it made a lot of sense. It was easy to understand. Then they got all crafty and then they're like, okay.
May I ask what else you do?
What else I do?
In your free time, yes?
What I do?
Well, apparently you read articles about AP tests. So I'm just
No,
wondering.
I just tried to make up a funny story. It wasn't very successful. I've tried my hand at art. Did I show you my art in this class?
The dog?
Did I show the dog in this class?
No,
So I was this happened years ago. I was finishing a problem, and as soon as I go like this, like, oh yeah, we finished. I got a little smiley face. So I don't know what possessed me, but one year,
I don't know.
possessed is probably the right word. I just kind of kept going. I'm like, oh, let's show that we're happy that we finished the problem. So I had a little circle, And they're like, oh, we can keep going. So like, art's not my strong point. And then I'm like, well, that doesn't really. So then I kind of kept going here like this.
Oh my gosh, just stop.
Oh my gosh. Okay.
So
You gotta finish it.
So
I thought it was a person.
It's a dinosaur.
Yeah, it's like a llama. That like turns into
what I really need to do is I need to like copyright the image.
I'm gonna make a T-shirt with that on there.
Yeah.
I will. I'm gonna do it.
I could probably get rich. It could go viral.
Happy. I'm making a T-shirt out of this. I'm bringing it to you. It might take me a bit because I'm lazy.
Yeah, that's kind of embarrassing. So what do they call it when, like, there's two sides of your brain, right? You gotta learn about this, right? What side's the logical side?
I don't know. I
The
don't know.
left is logical.
So I really think that this side of my neck is sore from pulling my head because it's so heavily left brain. I have to keep. Yeah, never mind. Okay. Let's get rid of that. That's kind of.
I'm the derivative of the.
More people in the hall. Hold on, sit right here. Hayden's there. Maybe I'll come to class prepared with a specific question. Please. Okay, somebody, tell me what to write. Go, like, read. There we go. 4 points. 1 for each letter. Somebody else. Go here, Grant.
Amount of grade.
Nice. So make a little table over here. Pay homage to Danica.
Wait, so do other calculus teachers, like, how do they teach that?
I don't know.
Like, and how is that successful?
If somebody asks me, I'll tell them, but I don't have time to go search them out. When I learned it in college, I just had to like keep memorizing. It's like really hard. That just organizes what I memorized so well that. Somebody else. 2 for Grant. Please, Mikhail.
Find the rates.
So what rates are described in the problem?
CZ, DX, and DY.
So we got dz over dt. Haley Heides claimed that as her future rap name. So, dz dt. So don't steal it from her. Two for Mikkel. Two for Elijah. Just trying to get more. You're doing great. Two for Rachel. Two for Allison. Two for Tristan. Two for Sarah. Ellie, go ahead.
You identify the amounts.
So what do I write here, Ellie?
So for dz dt, you're going to put 1. Oh no, you're just going to put z.
Much better.
And then x, and then y.
Perfect. 2 points. Please, Elijah.
So when they tell you information in the problem, does that come like in this step of the equation? Like when you're making the equation? Well, no, I guess that would come like after when you take this word of that.
Oh, let's talk about that. Let's talk. Allies up here. Everybody, look. Come on, look. Okay, here's a place where mistakes often occur. So we're going to fix it right now so you don't ever make this mistake. You're talking about a dynamic situation, which is true for most calculus problems. The whole idea is talking about things that are changing, right? So you've got this triangle that's growing, this rectangle, right? It just gets bigger and bigger and bigger. So just say it out loud. It's really simple. Is the value of z constant or changing? Louder. Okay. Is the value of x constant or changing?
Changing.
And y is the same thing. Okay. Because they're changing, you have to keep reminding yourself, okay, I can use these values anytime I want, but when I use them, it's only for a given instant. Like only at that instant is that value applicable. So for example, when x is 4 and y is 3, at that same instant, z will be 5, because it's a 3, 4, 5 right triangle. But only at that instant. So here's the big warning. Listen. We're going to create an equation, right? We've got our rates written down. We need an equation that involves the amounts. Somebody, what's the equation? Pythagorean's theorem. So I write down x squared plus y squared equals z squared. I'm not sure I'm answering Elijah's question, but stay with me. Okay, right here, you cannot plug in 3, 4, and 5. Like you can, and that confirms that at that instant, this is 3, this is 4, this is 5. But you can't plug in the numbers and then take the derivative, or you'll just get 0. So don't ever plug in things that are not constants prior to taking a derivative. You'll always get 0. You always take the derivative first, then plug in values.
Yeah, and then like another question. So like with that, will the amounts always be one constant and the rates always be that like dz over dt, like nothing else added to that derivative? Like that?
Oh, as far as the symbol?
Yeah.
Oh, yes, very good. Hey, 2 more for Elijah. Look. Yeah, that's perfectly consistent. Just like we say that column's f and the next column's f prime, it's exactly the same idea. This is z, this is z prime or dz dt.
And it'll always just say that.
Always the same.
Okay.
Yep. I suppose it could get really clever, but like I guess we've seen some problems that did this, where we said there was a number of mosquitoes, right? That's the amount. And then there was a rate at which that amount is changing. And in this particular problem, they happen to call this R. Okay? But it's still the same thing as n prime. And it's still exactly the same thing as dn over dt. Is that what you meant? Yeah. Yep. Cool. So again, remember please, don't plug in values that are changing prior to taking a derivative. You always just get 0. So this should be a big warning to you you've done something wrong.
Wait, say that again?
So don't ever plug in values that are changing before you take a derivative. You'll just end up with 0. So we need to take the derivative of this, so somebody tell me what to write.
Right. So d of x squared plus d of y squared, or just plus y squared.
Technically it would be the whole thing, although legally we can separate it.
Because
What goes here?
Over dt
Perfect.
equals d of z squared over dt.
2 points.
And then you do the addition rule, so then it's d of x squared over dt plus dy squared over dt.
Perfect. We'll do that one in our heads. Great.
And
Keep going.
that's 2x dx over dt plus 2y dy over dt equals 2z dz over dt. It's just tongue twisting.
You're doing great. Logan did stop by. So he talks a little bit. For Preston, question? Please.
So since you already took the derivative of that, and like, is this where you would plug in all the values from the top to find out that instant?
It's perfect. Yeah, that's the way you want to think of it. Okay, listen to what I just said. It was right on target. You've got this thing that's growing. So x isn't always 4 nor 3. They're growing, right? So we can't plug them in here and take a derivative and we'll get 0. Now that we have a derivative equation, though, this is valid at any moment. Like you can plug in the value of x, the value of y, and the value of z at any instant, and it'll work at that instant. This derivative equation also works at any instant. So we're going to use it at the instant when x is 4, y is 3, and z is 5. Rachel.
Would we want to use the dx over dt equals 3 dy dt at this point?
Yes, because we're trying to solve for what, Rachel?
dx dt.
Correct. So this one I leave alone because that's what I'm solving for. So then I go here and say, okay, I got 2, x is 4. I'm trying to find this. So I got dx over dt.
Why did you talk for?
Because at the instant we are interested in,
Oh, because we're plugging in. Now we got the derivative, now we're plugging in.
right, once we have the derivative, it's legal to plug it, say, again, so this derivative works at any moment. The moment we want to think about is the moment when x is 4.
Yes.
Perfect. So then Rachel said, I don't know the value of dy dt, but I kind of do. So what can I put in place of dy dt?
Since y is 3, you can just put 2 dx, right? Because dx dt equals 3 dy dt.
Let's ponder this for a minute. So I need something to put in place of this.
Could you do 1/3 dx?
There we go. Okay, let's stop there, though. Make sure that makes sense.
Yeah. Go ahead and go with that.
Wait, why did we do 1/3?
So it says dx dt is the same as 3 times dy dt.
Yes.
Yes.
But I'm trying to find something to put in place of dy dt.
Oh,
'cause,
yeah, and the 3 and the 1/3 just multiply to 1, right?
What I did actually is I said right here, I go dx, oh, they will, but maybe you and I are seeing the same thing and I'm just confused probably. Here's what I did. There's actually 2 ways you can think of it. You can think of the fact that you've got a 3 dy dt right here, and so that's the same
Yeah.
as dx dt. Is that what you meant? Yeah, that's true. Or you can move the 3 over. Either way. Anyone want more talk here? So then z is 5, dz dt is 1. Solve for dx dt.
And you're allowed to use a calculator on this problem.
This is no calculator.
Is it no
You don't need it.
calculator?
What's this? 8 times dx dt. Plus, this is 2 times dx dt. You got 8 dx dt's added to 2 dx dt's. How many do you have? 10. Please keep reminding yourself, hey,
1.
solving an equation means find the value that makes the equation true. So what's the value that makes the equation true? 1.
Oh, it was a long freaking day.
You're good. Anybody want to talk more here? Please.
Like, where do we use that information?
Oh, gotcha. So right here, we have our equation that, okay, so the way all related rate problems work is you get an equation that relates the amounts, and you take the derivative of that equation to get an equation that will relate the rates. Once we have this, we said, okay, dz dt is 1. So just plug it in. I'm trying to find dx dt, so I don't know that. But dx dt is the same as 3 times dy dt. It's the same as saying 1/3 dx dt is dy dt. So in place of dy dt, I put 1/3 dx dt. Like that. Does that make sense?
Can I make an announcement?
Sure.
The church just came out. Did everyone hear this already? Or am I was expecting it. I knew there was going to be something cool this Friday, and I was like,
Once a blue moon.
So there's an earthquake right
Show
there.
up.
Literally was
Show up.
Hey, you're not like that though, because you're in the first grade.
I missed that.
You can vote. Come on.
Okay, I'm ready. I'm ready.
For a hand. Come on. Cameron.
You would write down read.
4 points.
Right down.
Are we not doing it right?
My mom just texted me about the missionary thing.
You don't mind.
Everybody knows.
Your mom's awesome.
That's a minute and a half.
Now you make Danica's amount rate chart.
Nice. 4 points for that. I thought it was funny. I had students who, when I introduced L'Hôpital's rule, they're like, "Was that a student too?" That's actually a mathematician. So I get that everything I use is made up by my students, but I figure it's easier that way. It's true. Now what? Mikhail.
Find the rates that it talks about.
So 4 points for that. Somebody else? Rachel.
In the question, it talks about the area that the rate is increasing and the area that the radius is increasing.
So what would we write down?
dA dt for rates and dr dt, and
Well
then
done.
for the amounts you can do area and radius.
Perfect. 4 more. Ah, that would be wrong. There we go. Okay. Cambry.
And now you're making me
So now I need an equation that involves the amounts. So what equation is that, Cambry?
So if it's talking about a secondary region, would it be two?
Let me help you with something. There's 2 equations that I noticed students remember, but they struggle to keep them straight. Does that make sense?
Yeah.
Okay, so see, watch this. It really helps, in my opinion. If it doesn't, we'll find something else that helps. Okay, 2 pi r. And Cambry, what's the other equation? Your pi r squared. Okay, answer this question. Everybody in the entire room, answer this question. If you're measuring circumference, are the units going to be, just raise your hand if you know, inches or inches squared? Just raise your hand. If you're measuring circumference, think of a circle. You're measuring the circumference. Are the units going to be inches or inches squared? Show me your hands. Okay, everybody. Rebecca?
Inches?
How many knew it?
Dang it. I
2
just
points.
guessed.
No, don't guess. Don't guess. Look, just think. Circumference, what does circumference mean? Distance around. If you had to measure that, you'd grab a tape measure, right, and you would wrap it around. Tape measure, right, tape. And measure it so it's inches. That's why I know this is circumference, because the units are going to be just inches. Area is inches squared. That's how I keep it straight. Does that help maybe? So we want this one, right, Cambry? Okay, 2 more for Cambry. questions? Now what? Maddie,
Take the derivative.
tell me what to write.
Should be dA over dt, and then equals dt of pi r squared. Then you take the, yeah.
4 points for Maddie. Somebody else? Elijah.
So then the d pi r squared dt would become pi 2r dr over dt.
Perfect.
I'm not even paying attention now, like I'm out of focus.
It's okay. Life skill is, it's hard. It's hard for me too, but try to learn to compartmentalize a little bit. You kind of put that really good news in a compartment and you just keep going. So. Sarah.
It's equal to 96 pi.
4 points for Sarah. Question? Please, like.
So in the problem, we got that because it says that the area of the circular region is increasing, and that's the rate that it's increasing.
In fact, this one that one that Rachel was asking about, that was pretty devious. That really was 13 people, hoods, fire, black Dobermans. Okay. Sorry, people like Dobermans. Pit bulls, sorry, like pit bulls. Okay, look. This one, much better. And this is more consistent. They use the word rate. So read slow. The area is increasing at a rate. So right there, I know for certain this is 96 pi. Is that your question? 2 points. Somebody else? Avery?
So once you have that, then you divide by 2 pi to get 48 equals r times dRdt.
Four points for Avery. And Kate. I thought you were shooting. Somebody else? 2 points. Brennan.
Okay, so then when it says when the area of the region is 64 pi, can you put that to find R just into the area equation?
Perfect. So we said area is equal to pi r squared. The circle's growing, but the moment we are interested in, the area is 64 pi. So we know not only the area at the moment of interest, we also can figure out the radius at that moment. Four points for Brennan. Okay, pause for a minute. Again, don't just copy it down. Talk about okay, one of my biggest goals is helping you learn how to learn complex things, right? Like how you can apply this in any future class you take. Because I know that you're not all going to go become an engineer or whatever, okay? But if you learn how to learn, you can become whatever you want to become. So you're learning in this class to think as we go and keep thinking of the concept, the idea, like what big ideas are occurring over and over again that are going to show up in other problems. That's what you're focused on.
So is the 48 equals r dRdt, is that a rate that is still increasing? And so the other one where a equals r, is that the instant that we're trying to find it at?
So let me kind of summarize, I think, what you're saying is in general. 1 second. Okay, so here's the equation that gives us the area of the circle. And that works at any instant. Plug in the radius at that instant, find the area. Or vice versa. Plug in the area at some instant, find the radius. This is where we're in the process of finding a derivative, so we wouldn't want to plug any numbers yet. But this equation here is now valid for all time. This shows how the two rates are related at any moment.
But does adding the 96 pi, does that change the rate? Isn't that still it just tells how much the area is increasing? So
Right, because they said that the area increases at a steady rate, like the same rate all the time. So by putting a 96 pi in for this, and for dAdt, I don't cause any problems because the ADT is always 96.5. So I just put it in place. And then this equation now is valid for all time as well. And I said, well, I want to know what dRdt is when the radius is, whatever the radius is, when the area is 64. So that's why I went back to this equation to find out, oh, at this special moment, the radius is 8. So at that special moment, 48 divided by 8, the radius will be increasing at a rate of 6 meters per second. Or more fun. Question? Please. 8. Okay, there are two big ideas that people get mixed up. So we're going to take the opportunity on number 8 to review those big ideas. Okay, one of these big ideas is not associated with this problem. The other big idea is. So one big idea you worked on in the gold packet was this here. How do I find the derivative of an integral? So I'm making up a problem that looks kind of similar. Like maybe this is 5, and this is x squared. Maybe this is g of x. Okay? So we worked on problems. That stuff in the front there is written a little bit awkwardly. Let's fix that a little bit. Okay, so we worked on finding the derivative of an integral. This problem is different. It's not asking us to find a derivative. It simply wants us to find the integral. So you've got to keep straight the difference between these two problems. Here, not my favorite word, but we get a little bit of canceling going on. Between the derivative and the integral, it's not perfect, but it's a bit of canceling. So we learned that the rule says just grab the g, write it down, plug in the upper limit, multiply by the derivative of that upper limit. And then do the same with the lower limit. So that's how we find the derivative of an integral. Question. Up here is different. We're just finding the integral. So we'll pay the whole room. So if you have to find an integral without your calculator, what's the first thing you're going to have to do? Come on. Antiderivative. So I need the antiderivative of small f. Here's where Danica's chart again comes to your rescue. So I've got small f. I need to know what's over here. Like what's the antiderivative of small f? So somewhere in this description they're telling you what goes here. Ends up, you can see it. Who knows what I will write here and why I write it. So it's in the reading. Just got to read carefully. Focus.
Continuous function.
Focus. What goes here? Let's go, Tristan.
Big F of x.
So big F goes here, and the reason he knew that was they tell you that big F prime and small f are the same thing. So big F prime would belong in this column of Danica's chart.
What?
How many saw that?
Well,
4
they're
points.
equal to the same thing. Oh,
Right, they're the same, so they belong in the same column.
okay.
So if this is where capital F prime is, then you know from using Danica's chart that capital F goes there, which means capital F is the antiderivative of small f. So when I'm taking the derivative of an integral, I do not worry about antiderivatives. I just grab the integrand, go to work. If I'm doing an integral, I have to first find the antiderivative, and then I do plug into that antiderivative the limits. So that's how you find 8. So, are you comfortable that to find an integral, we have to find the antiderivative first? Okay. Are you comfortable that the antiderivative of small f will be capital F? So I find it, and now I have to plug in the limits so I can find the change in capital F. So I did. So this integral is that value. Two more.
Is this the fundamental theorem of calculus?
Huh? Fundamental theorem says that this integral is equal to this formula's antiderivative. Plug in. Good job, you guys.